what I mean, tell me what that means. That means what? The R, the ratio of the geometric series, that just means R is between -1 and +1. So if you have a ratio of your geometric series between -1 and +1, you can find this sum of the geometric series, which in the summation notation would, well, one way it could possibly look is like this. I mean, you can have some variation. A is just the base, but the n is the index. So we do have a geometric series. Turns out that equals S, they'll call it, and that equals, it's this. It's A1 divided by 1 minus R. So you do have to have the ratio. It doesn't work if the ratio is outside of those boundaries. If the ratio is 2 or 2.5 or -3, anything outside -1 to +1, you can't sum the infinite series. So I'm going from where? I'm going from 1, or it doesn't have to be necessarily 1. It could be 2 or 0 or any number. But then you go infinity. So you're counting. You can't even stop. All right. This series doesn't even have an end. However, it does have a sum, and it turns out the sum of that series is A1 divided by 1 minus R. For example, if I have, so the formula is a little bit simpler than the regular geometric sequence, some of the finite geometric sequence, but let's look at it. All right, so if I've got to sum n equals 1 to infinity 6 times 2/3 to the n. All right, so this fits our parameters, right? We're going to infinity, and so that's what we're looking for on these, to use this one here. The other thing is, of course, right here, this number is between 1 and -1, right? And that's my ratio. All right, so what is the sum of that? I mean, if I wrote out, I'd be going n equals 1, 2, 3, 100, 1,000, 1,000,000. I could do all those with n, but the sum total of all this is going to be a sub 1, the first term. What's my first term? First term would be 6 times 2/3 to the 1. That'd be the first term. What's that going to be? 12 over 3, which is 4. I believe that gives me 4. Divide that by just 1 minus R, 2/3, so it's 4 divided by 1 minus 1/3 is 1 minus 2/3 is 1/3. I believe if you do that, 4 divided by 1/3, 12. I do believe so. Right? All right. So what we're saying then is the whole sum here from 1 to infinity only amounts to 12. That seems like we're going way out there, but it turns out you only wind up with a sum of 12 infinitely out there. Okay. So let's look at another one here. What about the summation I equals 0 to infinity of 8 times negative 0.5625 to the I So again, that fits our parameters, doesn't it? We're going to infinity, so we're using, and we've got r's between, that's my r. So r is between -1 and +1. As long as that's true, then we can use this formula. All right, so start with the first term. What's the first term here? Well, it'll be 8 times -0.5625 to the 0 power. What is that? Well, that's 1, isn't it? Anything to the 0 power is 1, so that's, first term's 8. We've got 8 on top. Then down here I've got 1 minus, the r is -0.5625. So in actuality that'll be plus, so it'll be 8 divided by 1.5625. What does that give you? I get 5.12. 5.12. Okay? So it's just a simple little formula, and it works again. It has to be geometric, and it has to be r's between -1 and +1. So what we're saying is if I wanted to do n equals 1 to infinity, and it's 7 times 2 to the n, can't do it, okay? That one actually, there's no infinite sum there. The sum actually, because the sum actually just keeps getting bigger and bigger. What happens, the reason you can do it on this one is the terms eventually, as you get farther and further out, the terms are essentially 0. And so you're not really adding anything basically to it, but it's a little more to it. But when the r, here the r is bigger than 1, or if it's less than -1, either way, yeah, you just can't do it. There's no infinite sum on those. Okay? Yeah, for infinite, for the infinite ones. Now for the other formula, so we've got the other formulas. We've got the S sub n equals n over 2, a sub 1 plus a sub n. We've got S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We've got those two other ones to go along with this one. S equals, kind of write them out of order here, but yeah, so the thing is to know when you use them. All right, so this one again, we just did that one. That's the infinite geometric series with r between -1 and +1. That's when I use that. When I have the infinity symbol, and then on my sum, and r is between -1 and 1. When do I use this one? Well, that one I use if it's arithmetic, right? Which means it's a linear expression. Such as, for example, n equals 1 to 750, 6n plus 3, for example. That's when I would use that one, right? Because it's linear, first power of n. What about this one? Well, this one I can use anytime it's geometric, doesn't matter what r is. And it's geometric if you've got an exponential basically r can be anything. Ratio can be anything here. Doesn't have to be between -1 and +1. And so for example here we could have n equals 1 to 75 of 4 times negative 3 to the n. That's going to be a large one, but